Hi everyone, welcome back to my channel. The next thing we're gonna see will be the IPsec on the data tunnel. So it will be IPsec on data tunnel. So the IPsec tunnel will be formed between the vEdge routers. Okay. So let's suppose uh, let's suppose I have a laptop here connected. Okay, and it is it has some IP address x.x.x.x/24, and there is another laptop which is connected to vh2, which has a IP address y.y.y.y/24. Okay, so on this one you can see there's an IP address 1.1.1.1, this 2.2.2.2. Okay, so both vEdge routers are connected to each other through an internet link. So through IPsec, we can IPsec we can also achieve the confidentiality, integrity, and the last one is authentication. So first thing we have to first thing we have to know that the IPsec work on which layer of OSI model. So it work on network layer. Okay, and the tunnel which is formed between vEdge and the control device, whether it's a vSmart or vManage, like tunnel, the TLS and DTLS tunnels. So these tunnels work on the transport layer of OSI model. Okay, so the data tunnels formed between vEdges is going to be the IPsec tunnel, which is carrying the data traffic. Okay, so here it will form an IPsec tunnel, and this tunnel will carry the data traffic. And these tunnels which is formed with a control device, these tunnels carry control traffic, as in control policies. Okay, so the data traffic basically means an IP header having a source IP address and a destination IP address. Okay, so IP header having a source IP of x.x.x.x, destination IP of y.y.y.y, and these IPs added with, so x.x.x.x, and destination is y.y.y.y. So this IP header IP packet will include with a header of AES for encryption, advanced encryption standard for encryption. It will add SHA for integrity, and for keys exchange it will use, for the keys exchange it's gonna use the Diffie-Hellman algorithm. Okay, so before making connection, the vEdge1 what exactly does is the vEdge1 will start making connection with the vEdge2 over this this IPsec tunnel which is formed. So this VH1 will make a connection with um, VH2 router over this particular channel, which is basically called IKE, which is Internet Keys Exchange. Okay, and this IKE is basically the IPsec phase 1. Okay, and the purpose of this phase 1 is to share the capabilities of VH1 and VH2 in terms of security. Okay, so the capabilities of VH1 and the capabilities of VH2 means how secure the connection is. Okay, so this is the purpose of the phase 1, and for the phase 2 is basically is used to transfer the data traffic, to transfer the data over this IPsec tunnels. Okay, so I'm not gonna discuss about the IPsec protocol here, which include the phase 1 and phase 2. Okay, so you can see this one on means either you can Google it or you will find a lot of documents to learn about the IPsec. In future also, if I got some time to discuss about it, I'll discuss about this protocol in detail. First, we need to understand this one here for the keys exchange. For the keys exchange, we are using this Diffie-Hellman algorithm, and this is basically for IPsec. But for this TLS and DTLS, we were using RSA. We were using RSA for key exchange. So here we came to know a difference that for the control connection or for the control tunnel, okay, the algorithm which is used for the key exchange is RSA, okay, and for the data traffic or the data tunnels or you can say the IPsec tunnels, we will use the Diffie-Hellman algorithm for the keys exchange. So the IP packet which will be x dot x dot x dot x, which will be the source, and the destination is y dot y dot y dot y. Here I will add the AES for encryption, SHA for integrity, okay, and DHS Diffie-Hellman group for keys exchange, okay, and this part is called the IPsec header, okay. So this IP header is here which contain all this information, and now this IP packet, this complete IP packet is encapsulated in another IP packet. Okay, so this packet is encapsulated with another IP packet. So this is the IP address 2.2.2. So this one is encapsulated with another IP packet which will have a source of 1.1.1.1 and the destination of 2.2.2.2. So the inner packet is encapsulated, and on internet everybody will see the outer packet. On the internet, packet will go from this source towards this destination. The internet will see only this as a source and this as a destination. Okay, it will not see the inner packet. Okay, and when this packet will reach the destination or VH2, this outer header, this outer header will be removed and the IP packet will be decrypted using the shared secret and will be shared with this laptop which is on the destination. As we discussed about the secret S which will be shared between source and destination. Okay, so the packet will be encrypted using the same secret S, okay, and it will be decrypted with the same S at the destination end, okay, and after the uh, after decrypting the packet, this header will be removed and the inner packet will be shared with the destination device. The other thing we have to see in SD-WAN, so in SD-WAN, uh, so in SD-WAN, we will authenticate each device using certificates. So there is a concept of certificates in SD-WAN. Okay, so any traffic which is going in tunnels between controllers will be encrypted using DLS. Okay, as we discussed, we're gonna use the DH key exchange, which is basically Diffie-Hellman key exchange. So in this one, so this Diffie-Hellman key exchange in Cisco SD-WAN play a very crucial role in establishing a secure IPsec data tunnel between vEdge routers. So here between vEdge routers, the IPsec tunnel which will be formed, it will be formed through this Diffie-Hellman key exchange process. Okay, so how exactly the things will work here? Okay, this Diffie-Hellman key exchange will securely exchange the keys exchange securely securely over internet, which is an insecure network. Okay, so how these Diffie-Hellman group work in IPsec for SD-WAN? So first thing is a secure key exchange. So the secure key exchange means Diffie-Hellman is used to generate a shared secret key between vEdge routers. Okay, and this shared key is then used to encrypt and decrypt the data. So this shared secret key, which will be S. Okay, so Diffie-Hellman group will be used for these data IPsec tunnels. Okay, to generate this shared secret key S, and this S will be used later to encrypt the IPsec packet at the source end and decrypt the IP packet at the destination end. Okay, the second point which this um, Diffie element is used in IPsec will be for authentication. This Diffie-Hellman group will ensure that the key exchange happens securely without exposing the keys, even if the communication is an insecure network. Okay, and it help in the foundation of this IPsec tunnel. Okay, to create this data tunnel. So how this Diffie-Hellman work? Okay, so during the tunnel establishment between these vEdge routers, the IPsec tunnel between these vEdge routers, the two vEdge routers um, agreed on some parameters, okay, which include the DH group. So this DH group will determine the key length and the security of the keys, or the security or the strength of the key or the key exchange. Okay, then the key exchange process will start. So each vEdge generate a private key. Okay, so it will generate a private key. This one also generate a private key. Okay, and it will also generate a public key. Okay, so the key generation will happen, okay, based on the parameters, these parameters, which is key length and the strength of the key. After that, these public keys will be exchanged between the vEdge routers. So these keys will exchange each other, okay, between these two vEdge routers over this secure network, which is internet. Okay, and after the keys exchange will happen, okay, first the keys will generate and then the public keys will exchange. Then this shared key generation will happen. Okay, so each vEdge use its private key. So this vEdge1, okay, will use its private key, this private key. So this vEdge1 will use its private key, okay, and the public key of vEdge2. So it will use its private key and the public key, which is of vEdge2, okay, to calculate this shared key. Okay, to and so these, after using its private key and public key of vEdge2, it will create the shared key. The same thing, vEdge2 will use its private key and the public key of vEdge1 to generate the shared secret key using Diffie-Hellman algorithm, DH algorithm. Okay, after computing these shared key, okay, so these shared key will basically be same, okay, which will be generated at vEdge1 and vEdge2, okay, because the same key will be used to encrypt and decrypt the data traffic or the IP packet. So this calculation of the shared key will be same at vEdge1 and vEdge2. Okay, so the shared key calculation will be same on both ends, which will be vEdge1 and vEdge2, but this shared key will never be exchanged between the two vEdge routers. So the exchange will never happen of the shared key over the network. Okay. So this shared key at vEdge1 will use to encrypt the IP packet at the destination, and it will use to decrypt the IP packet. So the other thing is the Diffie-Hellman group. So this Diffie-Hellman group in Cisco SD-WAN, Cisco SD-WAN basically has multiple DH groups, okay, and each group offer a different level of security. Likewise, we have group 1, okay, which is basically 768 bits, okay, and this one has a low security, okay, and because of low security, it is rarely used. The second one is group 2, which has 1024 bits. This one includes a basic security. Okay, this will include a basic security, but it is not up to today's standard. So today's standard, this one is not up to the today's standard. So the next group will be in group 14, which has 2048 bits. And this group 14 is basically recommended for most deployment due to its balanced security and performance. Recommended for most deployments because of this one has a balanced security and performance. So the fourth one will be group 19. So this group 19 has 256 bits, and it uses elliptic curve Diffie-Hellman, which is elliptic curve ECDH, elliptic curve Diffie-Hellman. And this one has a strong security. Okay, this one has a strong security and more better performance. Okay, and the other group will be group 20, and this one has 384 bits, and it will also use the same elliptic curve Diffie-Hellman, and this is the higher secure, or this one will be using a higher security. Okay, and this one is used for most sensitive applications. Okay, so for more security, we have these three options: group 14, 19, and 20. So the other thing is, what are the advantages of using DH in Cisco SD-WAN. The first one is there is no need of pre-shared keys. Okay, so the key exchange happen dynamically without requiring any kind of manual configurations of keys. Okay, so we don't need to manually configure the public and private key here. Okay, it will be dynamically happen. The second advantage is security. Okay, so the shared secret key which will be generated using public and private key, this will never be transmitted over the insecure network. Okay, so as these keys will never be transmitted, so these keys will be resistant to any kind of interception or intrusion. Okay, and the third advantage is scalability. Okay, so these Diffie-Hellman key exchange support dynamic tunnel creation in large SD-WAN network. IPsec tunnel creation between these vEdge routers. So here comes the first phase, which is IK phase 1. The phase 1 will happen, and during this phase 1, Diffie-Hellman is used in this IK protocol, which is Internet Key Exchange, during the initial handshake to establish a secure channel for negotiation. So the initial handshake happen between this VH1 and VH2, okay, so that there will be an establishment of a secure channel. Okay, so basically there is a security association happen during this phase 1. Okay, then after there will be a like phase 2. Okay, and this phase 2, the shared key from this Diffie-Hellman is used to derive session keys for encryption authenticating IPsec traffic. Okay, so the shared keys, which will be the public and private key, will be used. Public and private key, both vEdge routers will be used to derive the session keys, which will be a secret key S. And this secret key S will be used basically for encrypting and authenticating the IPsec traffic. Then after that, there will be an data tunnel formation. So data tunnel, once this IPsec tunnel phase 1 and phase 2 happen, there will be an IPsec tunnel formed. Okay, and this IPsec tunnel, once established, is used to derive is used to transport the data. Okay, transport the data between vEdge routers. So that means securely transferring the data between vEdge routers over this insecure internet network. So basically, this Diffie-Hellman will enhance the security using DH group, which will be 14, 19, or you can say 20. Okay, and the same Diffie-Hellman group is configured on all devices. So Diffie-Hellman group will be configured on all devices, all edge devices, to avoid any mismatch during the tunnel formation or during the tunnel negotiation or security association process. This whole process of Diffie-Hellman algorithm ensure the secure and efficient communication, or you can say this whole complete process of IPsec tunnel formation make sure that data will remain secure, and there will be an effective communication between vEdge routers in SD-WAN network. Okay, so that's all for this video. Okay, and in my upcoming videos, we're gonna see some lab for the SD-WAN. Okay, and we'll see the different requirements in SD-WAN, and see what will be the interface, graphical interface, GUI, and CLI for edge devices. Okay, and we'll see the templates, we'll see the policies. Okay, so stay tuned for my upcoming videos. Okay, and if you like this video, please like it and hit a like button and subscribe to this channel for more videos like this. And thank you for watching. Have a wonderful days. Enjoy. Peace.